So today we are in the second lesson of Unit 2, introducing proportional relationships with tables. Today's goals are I can use a table to reason about two quantities that are in a proportional relationship, and I understand the terms proportional relationship and constant of proportionality. So we have a couple of vocabulary terms today in addition to the lesson. So, solving problems that involve proportional relationships using tables. Today's going to be another day we're going to have to draw a few tables in your notebooks. Actually, this entire unit, there's going to be a lot of table drawing, so it's something we're just going to have to kind of own up to and do it. So for your warm-up, it's called Paper Towels by the Case. It says, here is a table that shows how many rolls of paper towels a store receives when they order different numbers of cases. So this is a notice and wonder. I would like you to share, what do you notice and what do you wonder? One times 12. I notice for every case they get 12 rolls. Good. What else do we notice or wonder? Times 12 is the rule. Oh yeah, okay, so to get from the number of cases to the number of rolls, we're going to multiply, good, he's noticing I'm going to multiply the left side of that table by 12 to get my answer. I wonder why anybody needs 10 cases of paper towels. I don't know, maybe they own a business or they have a public restroom or something. That seems like a lot of paper towels. Corona. Yeah, that is true. There was a lot of hoarding of paper towels during the beginning of all of this, wasn't there? Actually, paper towels again are on another little bit of a shortage. I haven't been able to find them at the store for the last few weeks. I ordered my last batch from Amazon. Okay, so good. So we're looking at a table and we're seeing this relationship that if we know how many rolls are in one case, then we can determine how many rolls are in any number of cases. And as Kaden had shared, we're going to multiply by 12, and I think Nathan noticed that too. Nate noticed that too. So we also see a relationship in this table that goes from, for example, that third row to the fourth row. If there are 5 cases and that's 60 rolls, and you double the number of cases, notice that times 2 there, you're also doubling the number of rolls. So there's a relationship vertically as well. Okay, let's do an activity. This one's called Feeding a Crowd. I don't know why it says that. So, have we ever cooked rice? Anybody ever cooked rice? And give me a thumbs up or a yes or a why if you've cooked rice before. Yes, but failed. Yeah, eating rice or cooking rice requires a couple of things. So what are some of the steps to cooking rice? What do we need? We need water. We need heat. Right? Some sort of heat, a pan, something to cook it in. Yeah, so heat, water, and a pan or a bowl dish of some sort. How about a spring roll? Spring roll is maybe a fancier term, I don't know, for an egg roll. Have you eaten egg rolls before? I'm not a big egg roll fan. I don't really like cabbage. They have cabbage in them, I think. My husband loves them. He puts so much soy sauce on them when we get them when we do like takeout from Chinese restaurants, but so a spring roll is like a fried, I don't know, it's like a fried, I mean, they call them like egg roll sheets. I forget what they're actually called, but it's like a wrap. They take this stuff and they wrap it up and then they fry it in a pan. There we go. That's what they look like. Egg rolls. Oh, they're wrapped differently? Okay, well, there's something. I learn something new every day, don't I? But they're stuffed, and the ones that I don't like are the ones from Chinese restaurants. You can stuff them with anything you want, and then they're good. There are at, what's that restaurant? Chili's in Fort Wayne. They do this thing called a Southwestern egg roll, and that one's really good. It has like beans and cheese and chicken in it, corn. That one's really good. Yes, they are salty. If you like salty, soy sauce. Yes, soy sauce is very salty if you like that. Okay, so let's do an activity. I gotta skip forward to the table. Okay, so this table I'd like you to copy down in your notebooks, and then we'll take a few minutes to answer the 2 questions. Again, I want you to make sure that you've got an example in your math notebook so that later if you need to reference something, you can turn back and say, oh, okay, now I see how we got those numbers. So don't worry about the questions or answering the questions just yet. Let's get the table copied down first, and then we'll go through and talk about the questions together. I'll give you about a minute to copy that down. It's 5 lines long, 2 columns. Yeah, Connor, come on, man. So it says that a recipe says that 2 cups of dry rice will serve 6 people. So we see 2 cups and 6 people on the table. Then it also shows that 3 cups were going to serve 9 people. So if we were to try to figure out how many cups of or how many people 10 cups of rice will serve, we say 30. Let me see if I have this on here already. No, I don't. Okay, so that's 30 cups of rice. We can get this by several methods. Okay, some of you are probably, did anybody find a unit rate and figure out how many people does 1 cup of rice serve? How many cups of rice does how many people does 1 cup of rice serve? Yeah, it's going to serve 3 people. So if 2 cups serve 6, we're going to assume that 1 cup then serves 3. You can do division. 6 divided by 2 gives us 3. And you can see that pattern all the way down the table. 9 divided by 3 is also 3. 30 divided by 3 is 10. That's going to help us answer the last question of how many cups of rice are needed to serve 45 people. Think about this a couple of different ways. Yes, thank you for waiting until I actually asked the question. You can think of it a couple different ways. What number times 3 is 45, or you can do 45 and divide it by 3. And in this case, we get 15. There are some other tricks in these tables. Remember from the paper towel example, we saw that if you doubled your number of cases, that was going to double the number of rolls. Well, that works similarly here, and I'm going to do it with this second row on the table. But if 3 cups serve 9 people, how do I get from 3 to 15? Or I should ask, how do I get from 9 to 45? I have how many times the people? I had 9 people and now I have 45 people. How many times did I multiply to get 40? Yeah, times 5. So I have 5 times as many people. I'm going to need 5 times as many cups. So you can also see a relationship this way, multiplying by 5 on both. Oh, come on. That's a 5. Multiplying both of those numbers by 5 will get us the right answer there. Okay, let's look at another table. Please copy this one down, and also don't share any answers out until we get to the spot where I want you to actually be thinking about answers. Connor, I am specifically asking students to wait, not waiting. That's not fair to your classmates who are trying to think through the problem. So now we're going to kind of switch gears in the food that we're talking about. It's not rice anymore. Now we're talking about those spring rolls. So in this table, the only piece of information we know that goes across the table is that 6 spring rolls will serve 3 people. So how many rolls is that per person? How many rolls per person? Yeah, that's 2. We take 6 and we divide it by 3 and we get 2. So if it's 2 rolls per person, how many people will 30 rolls serve? And you can use either multiplication or division. We will talk in a little bit about that we always want to use multiplication again, similarly to how we do it with scale factors. So how do I get from the left side of the table to the right side of the table? How do I get from 30 to the answer of 15, which is correct? How do I get from 30 to 15? Yeah, we're going to divide by 2. And remember that not only can we say divide by 2, we can also say multiply by what number? Remember from scale copies that dividing by 2 is the same as multiplying by what? Yeah, good, a half. Half, awesome. Yeah, and that's from our work with scale copies. So we can either say multiply by a half, we can say divide by 2. We will talk in a little bit that it is always going to be multiplication when we introduce a vocabulary term. So what about 40? We're going to divide by 2 or multiply by a half, so we're cutting that number in half. 40 rolls would serve 20 people. And now we have to think backwards. Now we have 28 people. Remember we said 2 rolls per person, so to work backwards, instead of dividing by 2 now, we're going to multiply by 2, and 28 times 2 is, Connor had that earlier, 56, he said, and that is correct. So we looked at 2 cases here where we have what's called a proportional relationship, and we're going to define that term in just a moment. But what do you think it means to be in a proportional relationship? This table is an example of a proportional relationship. The rice example is an example of a proportional relationship. The paper towels are proportional. Yes, it has a rule. That's a cool way to say it. It does. It has a rule for sure. And if I were to stack up all these numbers, if I were to write 6 over 3, 30 over 15, I really should be doing y over x. I'm going to change that because I don't want to confuse anyone. I'm going to write it the other direction with a pen. If I wrote 3 over 6, and I wrote 15 over 30, and I wrote 20 over 40, what am I going to get every time when I reduce these? Whoops, that's supposed to be 6. What am I going to get every time when I reduce these fractions? What is 3 over 6 and 15 over 30 and 20 over 40? 26. Yeah, it's a half. So all of these are going to reduce to a half. It's from that first day when we worked on problems about gasoline, and I think there's a question about apples. These are proportional relationships. So let's define that. Under the two tables you've done today, please write down this definition, just this part that I'm putting in the circle or in the little bubble here. So a proportional relationship is when two quantities are always in the same ratio. And in that last example, the ratio was 1 person and 2 rolls, or 2 rolls per person. In the rice example, it was 2 cups and 6 people, or 1 cup of rice was enough to serve 3 people. Not in my house, we love rice. So in an example, again, so the relationship between the number of cups of rice and the number of people is proportional. Why? Because it was 1 cup for every 3 people. And it doesn't matter if you have 27 people, or if you have 100 people, or if you have 3 people. It's always going to be 1 cup for every 3 people. The number of cups of rice is proportional to the number of people. And you can see down below there's this little diagram. The green represents the cup of rice. The blue smiley faces would represent the people. So in that example you can see, or in that diagram, you can see 2 cups of rice and 6 people. So again, a proportional relationship is when 2 quantities are always in the same ratio. And I'll give you another minute to copy that down. Anybody need more time to write? You don't have to write down the example part down here, these 2 sub bullet points. So again, proportional relationship when 2 quantities are always in the same ratio. While some of you are still writing, remember tomorrow is an e-learning day. Right at the end of the lesson today, I'm going to go over to Canvas and show you how to access that. It's not quite up and running yet because the activity that I have planned, I'm going to be working with another teacher during our prep period today, which is 4th period. After 4th period, then you should be able to see the e-learning assignment, but I will show you how to get to it today. Okay, I'm going to go ahead and go on. Now we're going to make some bread dough. So here's what we're told. A bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. Some days they bake bigger batches, some days they make smaller batches, but they always use the same ratio. No, that's a great question, Hannah. You do not have to do attendance tomorrow. Some days they bake bigger batches and some days they make smaller batches, but they always use the same ratio of honey to flour. So complete the table as you answer the question. So again, I'm going to show you a table. Please be patient while everyone gets it written down. There we go. And you guys are lucky. You guys are fortunate because our class actually starts before 9 a.m. The 8th graders, their first class isn't until 3rd period in the building, which is your next class, wherever you guys go next. That's when the 8th graders start. And so that's after 9 a.m. And so many of them miss it because they get up in time for that class and the 9 a.m. deadline has already passed. I did just verify that with Mr. Deming, so I'm just waiting to hear back. But tomorrow there's no Skype or anything, so it will be... you know, it'll be more like a traditional snow day that we've had in the past where it's kind of on you to get your work done when it's convenient for you. So sleeping in is definitely a real possibility tomorrow for you. And then you have really the whole weekend to get that done. Okay, so let's take a look at this table. We are told that 8 tablespoons of honey are used for every 10 cups of flour. So first I want you to notice that in this table, we don't quite go in order there on the left-hand side. 8 and then 20 and then we go back to 13. This one's a little trickier, right? Because it's not as easy to see how do we get from 8 to 10. Is there a spot in this table that you can fill in quickly? Is there a place in this table where maybe you see a relationship like, oh, that got doubled or that's been tripled, so now I know the other answer? Because there is one spot here in this table, and tell me, yeah, next to the 20. Wait, hold on, Caden, there are 2 20s. The second 20 or the fourth 20? The one on the bottom or the second one? Which one's easier to figure out? Oh, maybe they're all easy for you. Yeah, the bottom one. So, Caden, if you don't mind, how many tablespoons of honey are needed for 20 cups of flour? Perfect. So we're going to go down and answer this question 3 first. And I tell students this all the time. If you know a certain line of the table without either having to figure out what number we're going to multiply by to get the right side or divide by, so this is, I'll speak for you hopefully, but this is a doubling. He's noticing doubling, right? 10 cups of flour doubles times 2 to give me 20 cups of flour. So that means I'm also doubling the honey, right? What happens if you don't double the honey? Does the bread taste the same? No, it's not the same recipe. And we talked a little bit about that yesterday with that drink mix. It's if you don't double everything, then you're not going to have the same it's not going to have the same taste, and it might not even come out right. Or if you're like me and you follow all the directions and it still doesn't come out right. I'm not a great cook. It's not my favorite thing to do because I'm not very good at it, but I try. Okay, so what makes this next part of this table a little more difficult? Again, there's not a nice, fun, easy number that goes from 8 to 10. I don't know how to multiply to get from 8 to 10. It's a fraction. It's a decimal. I don't know. It's ugly. What is it? How do we figure out how to get from 8 to 10? Remember this. We don't know how to get from 8 to 10. So 8 times what equals 10? And when we don't know, we're going to use division. So we're going to go backwards. We're going to work backwards so that we can figure out how to solve all of these problems. I take 10, divide it by 8. Yeah, good. It's 1.2. Okay, doesn't matter that it's a decimal. What does that mean? It means that there's 1.2 times the amount of flour than honey. Okay, right? There's a little bit more honey or a little bit more flour in this recipe in terms of number of cups than there is honey in terms of number of tablespoons. So now we've just found the number that will get us from 8 to 10. Well, we need to continue that pattern. So again, from 8 to 10 is times 1.2, and I know that doesn't show up really well, so I apologize for that. So now you can figure the next two lines out. If you want to grab a calculator, you are welcome to do that. And then once any of you get that answer next to the 20 and next to the 13, you can go ahead and type those in there. So we should be multiplying, right? Oh, my calculator doesn't work. Yeah, there we go. 24, 15.6. Chloe, how'd you get 9.6, if you don't mind sharing? I'm wondering if maybe you divided on accident instead of multiplied. Yeah, so 20, that's okay. 20 times 9, or no, I'm going to say 9.6. 20 times 1.2 is 24. And 13 times 1.2 is 15.6. I don't know how you're going to do 15.6. I don't know how you're going to do 0.6 cups, but we got the right idea. So, you know, in a bakery, I don't know how it works. I would guess that most bakeries probably make their stuff pretty fresh that morning. I know in a lot of the donut shops they do, but, you know, maybe you had a little bit of leftover bread from the day before, so this day you don't need to do as much, and that's kind of how that happens. So, again, we took 10 and we divided it by 8 to find what's the number, or as Kaden said, what's that rule that's going to get us from the left side of the table to the right side. And so then we found the rule to be today to multiply by 1.2. Awesome. You guys did really well with that. And now I'm hungry. Anyone else? Okay, so let's write down another vocabulary term, and this is constant of proportionality. Constant of proportionality, and we actually just found the constant of proportionality in all of our tables today. We didn't refer to it as that just yet, but the constant of proportionality is a constant ratio or a unit rate in any proportional relationship. So in order for it to be a proportional relationship, there has to be a constant of proportionality. In the paper towel example today, it was 12 because someone shared that if you take the number of cases and you multiply it by 12, we're going to get the number of rolls. In the rice example, the constant of proportionality was 3. 1 cup of rice served 3 people, right? We did 1 times 3 or 2 times 6. In the roll example, the spring roll example, it was a half, right? If I have 6 rolls, then I multiply that by a half and I can serve half as many people. In this example, what was the constant of proportionality? What was the constant of proportionality in this previous example? What number were we multiplying to get from the left side to the right side? Yeah, right, it was 1.2. So the constant of proportionality, again, make sure you have this written down, is a constant ratio or a unit rate in any proportional relationship. And we can always find it, we can always calculate it by determining how much of the second item or the second part of the table, the second quantity, is needed for every one of the first quantity. So when we did, there it is right there. In the bread dough activity, Oh, was it 1.25? Why do I have 1.2? I didn't verify. Okay, well, we're going to pretend like it was 1.2. I actually just did the calculation and it is 1.25, but we'll pretend like it's 1.2 since we already did all the work. Turns out when you take 10 and you divide it by 8, you get 1.25. And nobody bothered, or nobody verified that, including myself. So technically the constant of proportionality should have been 1.25 in that last example, but we'll do it in your calculator. 10 divided by 8. Because you're adding 2 more, and 2 is a quarter of 8. Yeah, 2 is a fifth, but, or 0.2 is a fifth, but yeah, it's 1/4. So don't think about it like that. So when you do 10 divided by 8, 8 goes into 10 one time with 2 left over. So it's like 8 remainder 2, and you do 2 out of 8, not 2 out of 10. 2 out of 8 is a quarter, so that's why it's 1.25. But it's not a big deal. Don't worry about it. We still did the problem correctly in terms of how we find our numbers. So again, in the bread dough activity, the constant proportionality we used was 1.2. That means you can multiply any amount of honey. So if someone says, hey, we only have 12 tablespoons of honey left today, okay, 12 times 1.2, oh, okay, gotcha. Take 12 times 1.2, and that's going to give us the amount of flour that we need. Constant of proportionality. You're going to hear me say this term a lot. Oftentimes when I go to write it, I get lazy and I write it like this. Looks like the word cop, capital C, lowercase o, capital P. Constant of proportionality. You'll see me do that. Okay, so let's talk about a couple of things. I'm going to stop sharing the PowerPoint this way. I'm going to share my desktop. Somebody asked me how many times a day I say that. How many times do you say I'm going to share my desktop? I say a lot. Let me know when you can see it. Okay, can we see it? I need to go to Canvas. Okay, so from Canvas, today, again, we go into modules if you want to, but today you're going to see a new module here up at the top. Actually, I'm going to go in as a student so you can see the student view. If I go into modules, you're going to see a new module at the top. That module will only be at the top when there is e-learning. It will not be at the top any other time, so you can focus on what's going on down here. So when we go to modules, I'm going to activate. You have a cool down today. You also have one Khan Academy exercise that goes with today's lesson, so that's also homework. Then what you're going to see after 4th period in this e-learning module, this is where e-learning will go. That is just for like snow days or school cancellations, or in this case the one planned e-learning day that we have. So that's where you'll go on a regular e-learning day. And what it will tell you is it will have the date like it does here, kind of like what we do down here at in the units, but it'll have the date and then your instructions, because again, we're not actually meeting tomorrow. So I don't have the ability to talk to you and say, okay, go to quizzes and type in this code. Remember that on quizzes, you signed up for the class. I didn't have a whole lot of you do that, so I'll probably also put the instructions here as well, because there's a code you have to join my quizzes class. So you have to join the quizzes class, and then I will assign the quizzes activity to you. But that's your e-learning. So sometime between now and Monday, you need to have today's cool down done, today's Khan Academy assignment done, and then also this quizzes activity. Do you have any questions today? Again, I will get that posted. It's just not posted quite yet because another teacher and I are working working on that activity together today to get that ready for you. I haven't heard back yet from Mr. Deming on the attendance, but I am 99.9% sure you do not have to check in that sheet tomorrow. So if that ends up being wrong, I'll make sure that the other teachers on our team can get that shared with you today. So you'll either hear from Mrs. Stein or Ms. Plickard. Mr. Lutman's not here today, so he must already have laid out on Canvas what you're supposed to do for his class, but he is not at school today. So have a great day. It's kind of like Friday a little bit. And if you have questions either today or tomorrow while you're working, please reach out. We are going to be in the building, the teachers will be, so I am able to, kind of hold like an office hours kind of thing. If you need to reach out, just do that and I'll get back to you as soon as I can. But other than that, have a great day.